Hi everybody, this is Dino Chris from Prehistoric Facts. Since this is supposed to be an answering questions episode, so there's no questions that I have gotten so far. But what I'm actually going to do today is actually talk about a very key subject in terms of paleontology and also geology is extinctions. Now, when we actually look at the past, we actually have 5 major extinction events. And basically, these events were actually the most had the most casualties in terms of how many species actually went extinct, how many plant species went extinct, you know, all that sorts of stuff. And basically, we'll actually go down all the way from basically the beginning all the way towards the present. Now, the first major extinction is actually the Ordovician. Now, the Ordovician extinction is still up for debate. One hypothesis is basically that at the end of the Ordovician, it was actually starting to cool. The oceans are starting to cool down, and basically some species of marine life that couldn't actually survive some of those colder waters that are actually being that are actually kind of coming up in terms of the poles, then it would probably actually cause some major extinctions. But there's another theory out there that says a gamma ray burst from a dying star actually blew off the atmosphere and actually caused like major heat waves throughout the planet. And I have a problem with that theory. You see, I don't really think that would have actually happened. It might have happened, but even though how close of a star would actually have able to actually hit the Earth in terms of its radioactive gamma rays to actually hit the Earth, and also it also depends on whether or not if that star is really that far away, it couldn't actually hit the Earth. The gamma rays wouldn't have actually able to actually hit the Earth. So I'm probably going to stick with the cooling hypothesis. The cooling hypothesis is basically the Ordovician started to get cooler, and that at the end of the Ordovician, the planet was beginning to cool, and that's why we actually start to see some ice caps that were actually starting to develop in Gondwana. And basically, Gondwana are basically the southern continents, basically made up of South America, Africa, Antarctica, and India. And you see, Europe and Asia were actually still right on around the equator during that time. So it would have been those regions would have been really warm. And I forgot Australia is also in Gondwana. And then next we actually go to the Devonian. The Devonian extinction, it actually happened nearly in the middle of the Devonian, and basically the Devonian is actually known as the Age of Fishes. And so, but even though there are some land animals on there, but they're really small. They're really, really small. Some amphibians actually started to crawl up on land, but even though they're really small, some lungfish are actually coming up on land. Again, small, and also basically, the reason why the Devonian was named the Age of Fishes is because of the large diversity of fish that has actually have evolved during that time. You got your armored fish, the placoderms, and also you start to see the first sharks. The acanthodontians are actually really common, and you get to start to see some fishes that actually start to show some strong fins on both the front and the back. So that actually, basically in the bottom. And those are actually kinds of fishes that actually develop into land animals. And those fishes actually might have had that kind of ability to actually try to start walking up on land, but even though they didn't really have the lungs, they didn't really have a lung system. And so that's why Tiktaalik is actually the missing link for that kind of period, and it happened in the Devonian. And so during an extinction, there's two theories for this. One is actually a gigantic volcanic event that actually has basically a giant super plume of magma that is actually basically on one area of the planet, and basically it actually goes into the oceans and also starts erupting on land. So, but even though I question this, is because I want to see more evidence of this. I want to see where the basalts are. Where are the flood basalt type of events that were actually going on during that time? But also another theory is that the Devonian was still getting colder. But even though in the Devonian we actually start to see some warming up a little bit more. But even though but it's more of a cooling hypothesis that is actually still the case, because there's still glacial material in some parts of Gondwana, in the continents of basically Gondwana, the Gondwana continents that actually had some glacial material. And also some species actually did die out, like the armored fish. The armored fish no longer exists after the Devonian, and that was because they're short-lived animals. It's because, you see, they couldn't actually adapt to the new changes in the environment, and that was the reason why. And the most famous placoderm of all time is Dunkleosteus, and Dunkleosteus was so huge it couldn't adapt, and basically the bigger you are, the harder you fall, and that's the reason why. And also it had a very small population. So when you're big, you have a small population, and also you go extinct really quickly. And so that actually has to do a lot of it. And then we get to the mother of all extinctions, and that is the Permian-Triassic extinction. Now, this is the motherlode of extinctions, and this extinction has killed off over 90% of all of life that is actually during that time, and this includes plant ecosystems and also some vertebrate ecosystems, and marine ecosystems nearly died out. And so that was actually a big problem. And the number one hypothesis for how this extinction happened was the flood basalts in Siberia, what are called the Siberian traps. And so a major volcanic eruption actually happened in Siberia, but during this time, in the end of the Permian and beginning of the Triassic, we actually see that all the continents are joined together in a supercontinent called Pangaea, and you see everybody lived everywhere. So that was the reason why there were some animals that went extinct really quickly. And when you have a flood basalt that actually happens on the northern part of the continent, and basically it starts, because then you see magma rises up, cracks through the crust, and basically you start to see multitudes of lava, magma spilling out. And what this does, it actually releases a bunch of gases that go into the atmosphere. Carbon dioxide, and also I think it was sulfur dioxide. And basically what it really does is, and what really happens is, basically you have two different kinds of periods of kind of climate changes during this time. The carbon dioxide will actually absorb heat, but the sulfur dioxide will actually bounce heat off. It would actually bounce heat off. And so basically you have periods of warming and cooling, warming and cooling, warming and cooling. But then to make things worse, where the Siberian traps actually are, there was magnitudes of coal. There was coal in where the magma actually cracked through. And when you actually mix heat, basically really high temperatures of heat, and you actually add coal, what do you get? Methane. And you see, methane is a bigger greenhouse gas than carbon dioxide. And you see what this does, it actually builds a big absorbent for the sun's rays to absorb more and more heat, and so you had multitudes of drought happening, and also in the oceans and also in the freshwater lakes and rivers, we start to see bacteria that is starting to grow that would actually release more methane and also produce a different kind of gas that could actually kill any land animal that was actually living in that time. Because this toxic gas, if you breathe in it, if you inhale it once, you pretty much are dead. So that is one reason. But there are animals that have survived this, and like some of the proto mammals that were actually around during the end of the Permian and then going into the Triassic. Some mammal-like reptiles survived, and then you have some reptiles survive. And so those were the kinds of animals that survived, and basically that kind of survived on through. But also sharks and some fishes actually survived in terms of the marine life. Then we go to the Triassic. The Triassic extinction is actually pretty much the point of where Pangea actually ends. It is the end of the end of Pangea. And what is it? And what this really is basically the North American the side of North America and Europe, and all along with Africa and South America, start to split away from each other, and so that actually is called the camp event, which is basically this gigantic tectonic movement that actually had the crust crack, and basically all of a sudden you're actually still spewing magma, and basically magma that comes up to the surface is called lava, and so that actually pretty much actually builds up more gases, and also it actually pretty much pretty much actually kind of heats up the atmosphere. And the animals that were around during that time were reptiles, and reptiles were actually the kings of the Triassic. Because the age of reptiles was the Permian all the way to the Triassic, and so that's where you see your first dinosaurs, and also this is where you see multitudes of archosaurs and some plant-eating reptiles, and so the archosaurs are pretty much starting to die off during this time, and when you're actually having a primitive lung system, then you actually are gonna pretty much not gonna survive very long. That's where dinosaurs had an advantage, and that was basically air sacs. And you see theropod dinosaurs and also the prosauropods. They had air sacs in their bodies to actually breathe in more oxygen than what the other reptiles would have actually breathed in. And also the mammals actually had an advantage too, and that was that some of the earliest mammals, they actually had that diaphragm, and that diaphragm is basically that muscle that is actually right below your lungs, and actually helps you breathe. And the reason why you're getting the hiccups is because your diaphragm is contracting. Is contracting repeatedly, and so that's why you feel like you are feeling like you're getting the wind knocked out of you every time when you hiccup. And that actually has pretty much actually caused that extinction. Pretty much the archosaurs didn't survive very long. The dinosaurs, after that event, they got bigger and diverse, and then you actually have the age of dinosaurs that has begun in the Jurassic. Now we actually come to the final major extinction, and that is the KT extinction, which is the most recognized extinction that is known in terms of history of in terms of the geologic history of Earth, and also in terms of paleontology. It's because you see it's that period of time where the dinosaurs actually go extinct. Now it's still debated on whether or not how this extinction actually happened. The most popular theory is basically a meteor or an asteroid has actually collided with Earth, basically hit the Yucatan Peninsula, hit the Gulf of Mexico, right where the Yucatan Peninsula is, and caused this humongous crater, and actually has created multitudes of events: tsunamis, shock waves, earthquakes, and like multitudes of other meteors from the impact actually just spreading out around the Earth, and that actually would have caused some fires that would actually have happened. But even though there's still some scientists that say no, that probably wouldn't have happened, it's because all those meteors wouldn't cause all those fires, and also the meteor impact in general would have actually heated up heated up a lot of that atmosphere around a certain region. But even though tsunamis would have actually been really terrifying, and also earthquakes, and some of these earthquakes can possibly go over 10 in terms of magnitude. And so, because if you're dealing with a large meteor or an asteroid, then you're going to have a really large earthquake. And so that's why you see the marine reptiles go extinct, and also the non-avian dinosaurs and the pterosaurs go extinct. And you see the mammals actually survive this is because reasons why is because there is a size factor in terms of how you can actually survive an extinction. Animals that were actually the size of a small dog or smaller actually survived. So take, like, for an instance, if you say animals that were the size of a beagle, you would actually those animals would actually survive. It's because you see those animals can actually hide into caves or holes or burrows, cracks in some of the rocks, and also some of the marine life could actually survive. Some marine life could have actually avoided some of these events just by actually going into deeper water and all those kinds of things. That's why sharks and other kinds of fishes, and basically turtles, and you actually have birds that have actually already evolved and they actually survived, and you get to the mammals that actually become the dominant dominant animals to actually dominate the planet and basically diverse into all the continents except Antarctica, and that's why you actually start to see some of these diversification of all these mammals that have actually happened in the Cenozoic, and that's where we're at. We're still in the Cenozoic, and basically we're actually still living through some of the things that could actually happen. And so the question is, what's the next extinction? What's the next major extinction? And that's always still debatable. One could be is that another large meteor could actually come and hit the Earth and basically kind of done the same thing of what happened to the dinosaurs. Or it could be a large volcanic event, but even though it's going to be highly doubtable about that, but even though, see, if Yellowstone actually has like a huge volcanic eruption that actually covers North America and parts of Mexico, then basically that region would just actually live through tumultuous events that would actually happen. But probably what a lot of scientists are thinking of is probably that the next extinction will be by our own faults. So basically is that we're humans diversing way too quickly, and also we're actually destroying environments, and that's the problem. And also we're killing off animals that are actually very important to the ecosystem. Because you see, if we lose some of the large fauna in Africa, then who are the predators? Who are the prey? That's really going to be the question. Insects will probably still survive, Most invertebrates will probably survive. Fishes and some sharks, and probably some of the small reptiles, some of the smaller mammals. How are we gonna go extinct? I mean, because you see, it could be anything. Could be anything that could actually happen. But we'll see what actually happens in terms of the future. But I'd say the next extinction probably won't happen for a good period of time, but it could be coming. It could be coming. So it's always out there. So we will never know when the next extinction will happen. All right, that's it for now. So on the 22nd, that will be a Sunday. I'll actually do a special episode. So I'll actually post certain types of dinosaurs that I would like to talk about. You guys can pick them, and I would actually do those kinds of dinosaurs. Now, I can do 2 dinosaurs in the same episode. Just keep in mind. And also, you can still send me questions by emailing me at dinochris71@gmail.com, or other ways you can actually post your questions on the Facebook page, Prehistoric Facts with Dino Chris. Like the page on Facebook, and you can actually submit your questions there. And remember, keep your questions short and to the point. You can also follow me on Twitter by basically following me with @CSGRALL. That's my Twitter. That's my Twitter page. Follow me in there, and I post pretty cool stuff there. Also, take care of the people around you, and also for you younger people out there, make sure to listen to your parents, your teachers, and your guardians. Those are the best motivation you can have for a good education. It's very important to have a good education, because with a good education, you get a good job in the future. All right, that's it for now, and I'll see you guys Sunday on the 22nd.